Hi. Um, it's not party time, but I do have my balloon here today, and it's got a mole of methane in it. What would be the mass of the gas in the balloon? Well, I hope you said 16 grams. But what would be the volume of the gas in the balloon? It's a mole of methane at STP. I hope you said 22.4 liters. Well, how many molecules would be in this balloon? Well, I hope you said 6.02 times 10 to the 23rd molecules. Once you've got that in your head and you know a little bit about stoichiometry, then maybe you're ready for limiting reactants. Let's do a limiting reactant problem where we're burning hydrogen. Well, you have to have a balanced chemical equation anytime you have stoichiometry, and so it would be hydrogen gas plus oxygen gas, a little activation energy, and you get water vapor. Got to balance. Oxygens aren't balanced. Hydrogens aren't balanced. There you go. Balanced chemical equation. Okay, so once you have that, in a limiting reactant problem, you would get two amounts of reactants. For example, let's say that we have 10 grams of hydrogen and 64 grams of oxygen. Okay, now in order to do this kind of problem, you have to know the limiting reactant. Once you know it, then it's just a regular stoichiometry problem. The first thing you have to really is convert to moles. Okay, so to convert to moles, 10 grams of hydrogen, and let's see here. I guess I could work here. 10 grams of hydrogen. 1 mole of hydrogen is 2 grams. So that represents 5 moles. So this is 5 moles. And we've got to change that to moles also. "64 grams of oxygen, 1 mole of oxygen is 32 grams. So this is 2 moles of oxygen. Okay. So, it looks like, well, we got a lot more oxygen, so hydrogen's probably the limiting reactant. But to be sure, we have to actually change to moles, and then maybe we'll have a better chance of guessing what the limiting reactant is. Okay, so we got moles. Now, here comes the tricky part. If we're not sure what the limiting reactant is, then we just have to take a shot. We just have to guess. Okay. So let's say that we guess the oxygen or the hydrogen's a limiting reactant. Let's say we guess this one's a limiting reactant. If we do that, then so this is what's present. Let's make a little table here to help us. Okay. This is what's present. Here's what's going to react. And here's what's in excess. Okay. If we choose this one as our limiting reactant, then all of it will react, right? And it's a 2-to-1 ratio. So if we've got 5 moles of hydrogen, we're going to need, it's 2 moles of hydrogen to 1 mole of oxygen. We're going to need 2.5 moles of oxygen. Okay? Well, if we go here and we say, we don't have 2.5. So the hydrogen's not our limiting reactant. We chose the wrong one. So let's go back and redo our table here. Okay? Let's change this, and we'll go ahead and erase this. And we'll say that the oxygen is a limiting reactant. We've discovered that now. Okay, so if the oxygen is a limiting reactant, then all of it will react, all 2 moles, and that would leave no oxygen left. Okay, it's a limiting reactant. Now we can go back and we can say, well, if we've got 2 moles of oxygen, 2 moles of oxygen, and the ratio is 1 mole of oxygen, 2 moles of hydrogen, we're going to need 4 moles of hydrogen. So, do we have that? Oh yeah. Yeah, we got that, and we've got some extra. We actually have 1 mole of excess hydrogen. So we can see here that now if we want to figure out how much water we got, we can just go ahead, how many moles of water? Well, 2 to 1 to 2. If it's 4 and 2, we can see we're doubling the recipe. We're also going to get 4 moles of water. Now, quite often, you have to report your answer in grams. Well, we could do that easily. We could change that to grams easily, right? 1 mole of water is 18 grams. And so that's 72 grams of water would be produced by this reaction. And sometimes you have to report your mass of excess reactant. There's 1 mole of hydrogen left. And we can change that to grams quite easily too. 1 mole of hydrogen is 2 grams. So this is 2 grams of hydrogen. Okay, there we go. That's how to do a limiting reactant problem. Sometimes they're more complicated, but basically you always use. Hi, I wanted to add, I cut myself off. Anyway, the basic idea of limiting reactant, once you've found the limiting reactant in the manner that I tried to show you, then the limiting reactant is used to find everything else. So that's a little bit I wanted to add. I hope that you are successful.